Okay, today we're going to look at decay. So, we're going to start off with our problem. Each year, the local country club hosts a tennis tournament. Play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So, the first thing we have to look at in order to solve this problem is our formula. So our formula for exponential decay is y equals a times 1 minus r raised to the x. So, first thing we'll do is plug in our numbers into our formula. So, y equals a times 1 minus r raised to the x. So, a is the initial amount you start with. And in our problem, it says that we start with 128 participants. So, we have y equals 128 times 1 minus r, which is our rate of decay. And it says during each round, half of the players are eliminated. So, we have y minus 0.5 because you write your percentages in a decimal. So 50% written as the decimal is 0.5. Then raised to the x power, which is time. It says how many players will remain after 5 rounds. So our x will be 5. Now we take our calculator and we just plug in these numbers. Y equals 128 times 1 minus 0.5 raised to the x. And we hit graph. And this calculator will give us a generic sketch of what our graph is going to look like. So that's basically what our graph is going to look like. Now, to get our numbers, we hit second graph, and we can have all of our coordinates laid out right here for us. So we'll make a table, x and y. So when x is 0, y equals 128. When x is 1, 64, 2, 32, 3, 16, 4, 8, and 5, 4. So this right here is our answer. It's going to take 5 rounds to get 4 players. So that right there is our answer. 4 players are going to remain after 5 rounds. And if we were to graph this, we'd simply sketch out our graph and plug in our coordinates. So 0, 128, can't do that. 1, 64, 2, 32, 3, 16, 4, 8, and 5, 4. Connect all the dots. And we have our exponential decay graph.